In this video, let's have a look at one of the questions from CSWA sample test of SolidWorks. Here I have the question, and this is the front view of the part that we are going to design in SolidWorks, and we have almost all the dimensions here. And this is the question. We have the overall dimensions, which is A, B, and C. A is 81 mm, so this is 81, and B 57. This is 57, and then we have C, which is the extrusion depth, and that is 43 mm. It is given that the material is AISI 1020 steel with a density of 0.0079 gram per millimeter cube, and the unit system is mmgs. So first we need to draw this on the front plane, and then we are going to extrude it. Let's go ahead and draw this in the front plane. First I'm going to draw a rough sketch, and then I'm going to use smart dimension to define the sketch. So front, first I'm going to draw a rough sketch. Then we have a 3-point arc here, and then it's going to be line, also here if you have a look at this, we have an arc, but the center point of this arc is somewhere on this edge. So I'm going to use a center point arc now, and use any point on this edge at the center and draw this arc. So center point arc, I'm going to choose this part, and here we have the arc, and then we have another arc with radius 5. So I'm going to draw another arc. Let's draw a tangent arc and line. So here we have the basic structure. Now I'm going to use smart dimension to fully define it and make it look like this. First I'll give the overall dimensions, which is A and B, and then I'm going to start smart dimensioning from this side. So first A and B, smart dimension. This is 81 mm, and then this is 57. Okay, and now we have 7 with an overall height of 32, and the angles are 45 degrees. So from here till here it is 32, and this is 7. This one here is 7 again. Then we have the angle between this edge and this edge is 45, and this edge is 45 again. Also we have this distance as 14 mm here, so select this one and select this edge, make it 14. And then we have a relation here. If you have a look at this, we have a relation saying it's tangent, and then we have an angle of 10 degrees. Let's add this relation and dimension here. So this edge and this edge have an angle of 10 degrees, and we're going to add the tangency here. Select this arc and select this edge and add a relation saying it is tangent. Now I'm going to add this dimension here. It is 19. Okay, so R is 19, and we have this dimension as 29. So from here till here it is 29. Okay, and this is 5 with an angle of 45. 45, and the angle here is 45. And from here till here it is 24, as you can see here. I'm going to make a slight change and exit smart dimension. I'm going to edit it a little bit. Now we're good. So we have added all the dimensions here, and we are going to add dimensions here. Here the distance between this point and the center point of the arc and the base point is base edge is 19 mm. So smart dimension, select this point and select this edge and make it 19. Okay, and then we have this as 29. Okay, and we have this dimension as 29 here. 29. Okay, and there is a relation here. It says it is tangent to this, so let's add the relation first. Select this arc, add a relation saying tangent. Okay, and do the same over here. Select this arc and select this line, tangent. Okay, now I'm going to add another dimension here, which is the radius of this arc, and it is 5 mm. Okay, now we have to add this dimension here, which is 19. So from here till here it is 19. Now the sketch is fully defined, as you can see. Exit smart dimension, and we are also going to add this hole right now. Instead of doing it later, we can do it right now. So first I'm going to draw a circle, random circle of random radius, and we can add the dimensions later using smart dimension. Here the distance between this edge and the circle center is 14 mm, and the distance between this edge and the circle center is 14, and the radius of the circle is 14 mm. Sorry, diameter of the circle is 14 mm. So smart dimension, 14, and from here till here it is 14, and from here till here it is 14. Exit. Now we have the fully defined sketch. What I'm going to do is I'm going to use extrude boss or base feature to create this, and C is 43 mm extrude boss or base, and C, as you can see, it is 43. Click on OK. Now go to trimetric view. So we have the design here, the same one, and now we need to assign the material. Right click on the material over here and click on edit material. Now we have steel. Under steel we have AISI 1020. This is what we are going to use for this part. Click on apply. As you can see, the mass density is 0.0079 kg per centimeter cube, which is same as 0.0079 gram per millimeter cube. So apply and close. So now the material is applied. What we need to do is we need to check for the mass. Here it is asking for the overall mass of the part, so we are going to check the overall mass of the part. So to do that, what we need to do is we need to go to evaluate and then mass properties and click on recalculate here. It says 939.54 grams. So the mass of this part is 939.54 grams. Close. This way you can find out the mass of an object or of a part using SolidWorks.